It is now my true pleasure to introduce our first two speakers, which will welcome you to this building, but also to Intelligent Systems Engineering here at Indiana University. And the first gentleman is Geoffrey Fox. He is our interim Associate Dean for Engineering. He is also the chair of the Intelligent Systems Engineering Department, and he is a distinguished professor in ISE. Geoffrey Fox received a PhD in theoretical physics from Cambridge University, so he has the really most interesting and astonishing outfit whenever we have our graduation ceremonies here. He works in applying computer science from infrastructure to analytics in biology, pathology, sensor clouds, earthquake and ice sheet science, image processing, deep learning, manufacturing, network science, and so on. And his infrastructure work is built around software-defined systems on clouds and clusters, with analytics focusing on scalable parallelism. Second welcome will be done by Brad Wheeler. He is the IU Vice President for IT. He is the Chief Information Officer here at IU, and he's also a professor in information systems at the Kelley School of Business. You might know Brad from his work as a co-founder and leader of many multi-institutional collaborations. His recent work focuses on the Unison Consortium, on Kuali, and also on IU's mass media digitization and preservation effort. So please welcome both of them here. Geoffrey will go first, and then Brad is going to take the stage after him.
Okay, thank you very much. So I'm going to describe the Intelligent Systems Engineering Department. And the first few slides try to explain what intelligent systems is, and also tries to say why we're not the same as some other engineering activities. So intelligence, this is just, all right. Is there any way to get, I can't hardly see that.
If we click to the next slide, it'll then show.
Sorry?
Yeah.
Oh, I see. Sorry, I was off by one on the slide deck here. All right, so intelligent systems is, at least as interpreted by us, it means the fact that, let's take an example of the work I do with Kansas on analyzing data from radar flying over ice sheets. So the engineers at Kansas, they design the radar, take the data, run the MATLAB signal processing, and then that's the end of their engineering. And what we do is take that data, do the image processing, and find out where the glacier beds are and where the snow levels are. So we view intelligent systems engineering as going all the way from that radar through the final decision as to what the bed of the glacier is, and then we can follow that up with an HPC simulation of the motion of the glacier and try to understand better why the glaciers are disappearing. And so that's intelligent systems. And then if you look at the parts of engineering that we've chosen, they tend to be those involving embedded systems, small-scale systems such as the Internet of Things. And as I've already given in that example, they have a big data component. And this picture here shows the structure of the program. We have six. Actually, we actually have 7 tracks. The one track is intelligent systems, which is sort of the middle blob. Then we have 6 actual specializations, which are listed around the edge. You can see that computer engineering, cyber physical systems, environmental engineering, nanoscale engineering, neuroengineering, and bioengineering. And notice we do not do mechanical engineering, civil engineering, and which are, of course, very important. In fact, they're the most popular engineering subjects, but we do not do them. All right, so then in the middle, we have these sort of core capabilities. And also another one we don't do is electrical engineering. Electrical engineering is part of the program, but is not taught as a separate discipline, a separate track. If you could say that cyber-physical systems replaces electrical engineering. And in the middle, you'll see sensors, Internet of Things, big data, high-performance computing, and of course, classical engineering, signal processing, information theory, and control theory. And this is sort of saying some of the same things again. We do, as we do cyber-physical systems, we do edge computing and embedded systems, and of course we have nanoscale sensors on the edge. Then in the we also do cloud computing and high-performance computing, which is sort of the central resources used to interpret that data. And all students will have classes in those areas. We were recently rated, I think, number 10 in the world for engineering programs having artificial intelligence, because all our students get machine learning / artificial intelligence courses. So I just wanted to note that this fits the headlines. You will see, if you browse the web, they're all the companies like Google, Microsoft, and so on, Facebook, they're all saying that they're AI-first companies. So you could say that we are clearly targeting AI-first engineers. So maybe we can help them staff their companies. All right, so that sort of tries to get you an idea of what we're doing and why we're called intelligent systems. Let's go into the last few slides. I'll give a little bit more detail. So we have, at the undergraduate level, four of those 7 tracks. And at the graduate level, we offer the three tracks: the intelligent systems, environmental engineering, and neuroengineering. And you can ask why we don't do everything at the undergraduate level. I can assure you it's very hard to offer, starting from scratch, to offer all those tracks. We have more than enough work to do. I should say that currently we'll see at the end we have 19 faculty now. I think to offer these programs as we've outlined needs about 35 to 40 faculty, which we will reach in about 5 years' time. We also, to show what you have to do when you set up a new program, we have 67 courses. And we have several, like robotics, we haven't actually submitted yet. So 67 courses is not so easy to devise from scratch. Some of them are, though, related to existing courses. All right, so here is the actual undergraduate degree. And one interesting feature of it, I mean, it's a very solid engineering degree. It has 69 credits in the degree, which is comparable to those at other engineering schools. It is different from almost everything else at IU Bloomington, which has more like 45 credits in a major. So engineering here has credits which are similar to other engineering degrees, but we at least give them the option of doing it in 120 total. Like in some engineering schools, you have to do 130 credits. And below this, we give a little bit more detail about what some of the courses. There are 30 credits, which are taken by everybody. And then there are groups of core courses in computer engineering and cyber-physical systems. There are 15 credits, which are in common between those 2 degrees. And then they separate out for the last part of their study. And bio and nano have, again, some in common, and then they separate out. The bio and nano degrees take a lot more chemistry and biology. They have a lot of chemistry and biology in their requirements. All right. So here you can see the computer engineering track, and we have a total of 50 students in the first 2 years, 55, sorry, 55 undergraduates, and we're at the middle. We're on the right. We're in the second year for the initial cohort, and they're just doing intelligent systems 1, computer systems, and the statistics and science elective. Next semester, they'll do intelligent systems 2, which I'm teaching. That's cloud computing and machine learning. And you can see I have a classic engineering course, signal processing. They're having cyber physical systems. So already this is the core, which is going to give them a pretty broad, all students a broad knowledge. Then here, the last 2 semesters at the bottom of this slide, that will be different for the CPS. It's different for CPS and different for bio and different for nano. The top part of this slide is common for all the tracks. All right, so everybody asks us whether we're ABET accredited, and the answer is easy. We're not allowed to be ABET accredited until we graduate a student, and we will try to be ABET accredited when we graduate some students in 2020. And I believe that it's expected that we're trying to keep track of our processes, so we will meet the ABET requirements. And we're reasonably optimistic we will get the accreditation reasonably soon, and that will be retroactive to students here now. Then obviously, if you're students, we have various scholarships, and we also have a pretty active program to support the undergraduates to do research with faculty. We offer them financial support to do summer and academic year research. They can either take it for course credit or for or to be paid. And we have actually, Cardi did a lot of work here. We have a nice summer camp program which we're expanding next year. I should say, and another, I didn't mention that we've just actually, there are all these things you have to do. So we've just introduced our minors at the undergraduate level, because we think there are going to be quite a lot of existing IU students who want to do a minor in engineering. That's going to be 5 courses. And we also have a set of PhD minors, which has all those 7 tracks, but also has big data engineering as an allowed track, which is also aligned with how we hope to support the data science program here, offering a data engineering track in data science. So you can sort of see how we've managed to take our core engineering concepts and expand them into these intelligent systems areas. And my last slide is the faculty. Those at the top in black are the least important. They're the existing faculty, and the tenured. The heart of our faculty is those in brown. They are the new faculty, and you can see there we've actually hired effectively people in all 6 tracks. Like Lantel Lu, he is actually a cyber physical systems, but he's applying cyber physical systems to marine robots, and so he has an environmental flavor to his work. And we have a couple of people in neuroengineering, and we have the intelligence systems. Minji is in that. He was our first hire in intelligence systems, Minji Kim, and we expect to hire more in that area this year. So we have effectively all our programs started, but to really offer, say, an undergraduate degree in bioengineering, you're going to need, or actually any of these tracks, you need around 8 faculty. And so it is not possible, I believe, to offer a full-fledged undergraduate track without some faculty numbers such as that for each of the tracks. And that's how we get this number, 35 to 40 total faculty, which we'll reach hopefully in around 5 years, which will be a sort of preliminary, fully staffed for these initial plans. Thank you.
I think now it's Brad Wheeler's turn.
heart disease,